In this video, I'm going to show you the setup in Mechanical for your inertial wing design. When you import the geometry into ANSYS Mechanical, you should see you have one body with subparts because we have shared the topology. So if I click on surface, that's the skin surface, and again, we have only the mid surfaces here, and then we have the rib and we have the spar, and you can rename it, and you have to give it a thickness. Each of these a thickness, and that's a design variable. I just gave it a fairly substantial thickness, which we can visualize in the mesh, just because otherwise I was getting large deformation. This model doesn't have enough spars or ribs to use low thickness. So that's something you want to play around with. So you give it the thickness, and then you give it the material assignment, and you have to make sure that that is the right material. I've used steel here, which is the default. You'll have to create a new material, aluminum, and as per the project definition. And then under connections, you shouldn't have anything because of shared topology. And mesh, what I did was I changed the element size to 0.1 meters, and under statistics, if I look, that's around 17,000 nodes. And each node has 6 degrees of freedom. And for a shell model, the degrees of freedom are on the normals. So 3 translations of the normal at the node and 3 rotations. And then if I zoom in, I can see what the mesh looks like, and you can see that this the trailing edge, we have like 1 division across that. That should be okay, and because we'll see that the highest stresses are going to be at the spar location. And then if you go to display thick shells and beams, this is just a visualization of the thickness, and you can see that where the spar is meeting the skin, we get non-physical effects because of the assumptions made in shell theory. So this part is not modeled exactly. And I like to turn off thick shells and beams. And then in terms of the boundary conditions, if I applied standard Earth gravity, so the density is important. If you're applying, the body force. So, and I gave it in the -y direction. So and that you can, if I go to environment, I can access that from inertial standard Earth gravity. And then I put in a fixed support on these 5 edges. And I can pick one of the edges, and I can go to selection and say extend. So if I pick an edge and I select that, I can go to selection limits, and it will select all the edges that are contiguous with it, and then you need to control click, select that edge, and also the trailing edge. So you'll have to zoom in here and control click. So you should get 5. I think I did it right. Maybe I forgot to include the trailing edge. That shouldn't have a huge effect, but perhaps that's also going to be fixed to the fuselage. Okay, so that's going to zero out all displacements and rotations of the normal at at that location. And then for the aerodynamic pressure, this is the pressure on the top surface, and you can see I have 4 faces. So it would be 1, 2, 3, 4, 4 faces, and then I gave it the pressure is in the upward direction, and I gave it the magnitude, and so you can look at the arrow and see what the direction is, and that depends on the direction of the normal. So if I, in this view, it looks like, those edges are not, those faces are not selected, and actually it highlights the underside of those faces, and that's because the direction of the normal. And if I go back to discovery, let's see, if it'll let me go back over here, I can go into measure and say normal, and if I select the surface, let's see, it shows that the normal is in the downward direction, and I can actually right click and say reverse face normal. And if you do that, this normal will be facing the other way, and then you will have to flip the sign of the pressure magnitude. The only nice thing about selecting, the normal being pointed in that direction is the red would be highlighted on this side, but it's not a big deal. So you have to kind of manipulate the model and maybe even go to display wireframe to see, that you've selected the right surfaces. So I have the top surface, and I have a pressure of 6,000, which is in the upward direction, and then I selected the bottom surfaces, and again you can see, if I go into the wireframe view, I can see those surfaces, and here I had to give it a negative minus 2500 pascals to get it in the right direction. So either you can give negative here or flip the normals, either one works. So that is it for the boundary condition. So let me just go back to display shaded exterior and edges, and then under results you can look at the total deformation. If I go to results, this is auto scale, and I can play it, of course, to check the boundary conditions. In fact, maybe I didn't, let's see, I may not have the directions of the pressure right. Let's see, that's 6,000 pascals, and that's minus 2,500. So you'll have to play around with the direction of the, whether you need to give a negative sign or not for the pressure, or you could just flip the normals. Probably that's going to be cleaner in discovery, and just update the geometry, which you can do under geometry, and you just say update geometry from source, and it will bring in the latest geometry from discovery. So then you can look at the total deformation, and you can look at the equivalent stress, and you can see that the maximum occurs in this location.